One of the ways that companies and really organizations in general can obtain financing is through the use of bonds. And sometimes there are a number of reasons companies might want to use bonds. I'm just going to mention one that's on the top of my head. Sometimes the amount of money that an organization needs to borrow is so big that there really is not one financial institution that legally, because financial institutions have legal lending limits. There's government regulation to make sure that we don't have another Great Depression kind of thing happen. No more bank runs. So banks have a limit to what they can lend. Sometimes then, there are a number of solutions for that, but one of the options is to issue bonds. And it's not the only reason that companies issue bonds, but it's a reason. And the way a bond works is basically multiple investors will loan money to the entity, and then the entity will make interest payments to those investors over the life of the bond, and then at maturity they will repay the face value to the investors. So as we're trying to figure out, how do you figure out what is the price of a bond, we really are looking at the present value of future cash flows. So let's think about a bond situation where it's going to be issued at a premium. How do you know it's a premium? Well, what I look at, and sometimes I've never used Tinder. I always have to say, is it swipe left or swipe right? When I delete my emails on my phone, I'm swiping left, so it must be swipe left, okay, to say no on Tinder. So what will we do here? Why is he talking about Tinder? Well, I'm talking about here a bond that is more attractive than the market. So I guess that would be swipe right, okay? And the reason it's more attractive is because similar investments in the marketplace, similar risk, paying 4%. These bonds pay 6%. They are more attractive than the marketplace. Swipe right. And if something is better than the alternatives, it's going to sell for a higher amount. So we should expect that this bond will be issued at a price that exceeds its face value, exceeds $100,000. Let me just prove it to you. Now what we have to do is we have to take the present value of a single sum, okay? And that's the $100,000 in the future. Okay? So we take the $100,000 and we're going to use the market rate for our discount factor, not the stated rate. That 6% you see up there, that is going to be used to figure out what are the cash interest payments. We'll talk about that more in a second. So 4% rate, and the term of this bond is 4 years. We get a multiplier, 0.85, and some change right there. Let me just get that up on the screen for us. And what we're seeing is the present value of that single amount of cash flow is $85,480. So what we're basically saying is $100,000 4 years from now at a market rate of 4% is equivalent to $85,000 today. But that's not where the fun ends, because we also had the present value of the ordinary annuity. Now, the payment amount is going to be $6,000 per year. Where the heck did we come up with that? That's the periodic interest payment. Remember, these bonds, they offer two things to investors: periodic interest payments, and they get the face value at the maturity of the bond. So take the face value times the stated rate, and that's going to be our annual cash interest payment to the bondholders. I know that that totals to $24,000. $6,000 a year times 4 years. But what we have to do to figure out the present value, 4% market rate, 4 years. Here's the multiplier right there. And multiply that periodic payment times the factor in your table. And yes, I know you would probably lean on Microsoft Excel or a financial calculator or something like that, but we're going to continue to use this illustration. Now the bond price is going to be the sum or the total of the present value of the face value and the present value of the interest payments. If you combine these two amounts, we're going to get a present value combined of $107,260. That is your bond price, guys. And as I predicted, and I'm glad that my calculations didn't disprove me, this bond will sell at a premium. It'll sell above the face value. So basically, because this bond is more attractive than similar risk investments in the marketplace, 6% is better than 4%, investors will be willing to pay a premium to access these wonderful 6% interest rates and that future face value. This is the same scenario we looked at just a moment ago. The only difference is now the market rate of interest is identical to the rate of interest that these bonds pay. And just to kind of prove things to you, when we had a market rate that was lower than the stated rate, we had a premium. And spoiler alert, in a couple minutes, we're going to take a look at a situation where the market rate is bigger than the stated rate. And those bonds are going to be issued at a discount. But when we do the calculations, the present value of the single face value and the present value of the interest payments, we should come up to $100,000 when the market rate is equal to the stated rate. So let's just do the math on it. We're at 6% for both of these tables. I'm sure by now you're getting pretty adept at using these tables. If for some reason you have any questions, there is a separate video available. Just look where you found this one and you'll find a video on how to use these tables. There's our multiplier for the single sum. There's our multiplier for the annuity. Let's add things up. I'm going to abbreviate the calculations a little bit because we don't need to be redundant and bore you guys completely to death. So we take the face value of the bond and multiply by the present value of a single dollar amount because it's one cash flow. 4 years from now, that's $100,000 going from the borrower to the lender. So the present value of that cash flow is $79,209. The interest payment is still $6,000 every year. That's not going to change. We're contractually obligated here in the bond indenture agreement to pay 6%. So it's still going to be $6,000. The present value is going to look a little bit different though. Okay, so there's our factor from the table over here and the present value of that stream of cash flows. I am doing just a little bit of rounding. I mean, these things go out to many, many significant digits. But as you can see, if you take the present value of the face amount, the present value of the interest payments, that does add up to $100,000, which is exactly at par. So think about golf. If you're supposed to reach the green in 4 shots, that's par. Same kind of thing here. The bond price is equal to the face value because the stated rate matches the market rate. This is the same fact pattern we've been dealing with, but now we have a stated rate that is less than the market rate. Okay? We're going to swipe left, guys. Well, we're going to swipe left, or we're going to want a discount. Okay? Think about this as being like a dented car. It's like, well, sure, I'll buy your used car, but I noticed there are a couple dents there, so you're going to have to knock a little bit off the price in order for this to be a reasonable deal for me. Same kind of thing here. This bond has some defects. And, well, one major defect is that it pays interest at 6%, but the market rate is 8%. So a reasonable investor would say, I'd rather earn the 8%. So we should expect that this bond price will be less than $100,000. If it's not, then you swipe left. So take the $100,000 face value we've been dealing with, and we're now dealing with a market rate of 8%. Always use the market rates for these calculations. Okay. And then we go over here is the multiplier, 0.735. What do we have? 030. The math isn't too difficult on that. That's why I picked $100,000. You can imagine I probably should have made the interest payments that as well. Then we would have had really easy math. Now the interest payments, it's the present value of an annuity, so that series of cash flows. And what did I say, 4 years, 12%. The multiplier here, 3.3, whoops, I was off there, 3.312. So $6,000 times 3.312127. That's the present value of the stream of interest payments. Combine these amounts, and we come up with $93,376. As promised, because this bond is not as attractive as the marketplace, it's going to issue at a discount, okay? And what you're going to see in a minute, we're going to look at how to amortize the discount or the premium over the life of the bond. A couple different methods we'll take a look at. But what you're basically seeing here is this discount, which in this case is roughly, what, $6,600? That is hidden interest expense for the borrower, and it's hidden interest income or investment return for the lender. Because think about what's happening. You're going to get the $6,000 every year for 4 years. Wonderful. And, oh, by the way, what was the cover charge for this party? You invest $93,000 today. You receive $6,000 a year for 4 years. And then at the end of the 4 years, you're going to get a check for $100,000. Not a bad deal. Now, the only reason you were willing to do that is because you had this discount. So that $6,600 of discount that we're seeing here, $100,000 minus the 93 and some change, that is essentially the amount that is needed to equalize the stated rate with the market rate. This bond will effectively pay interest at 8%, which is the market rate. And for that matter, let me just go back a couple slides. I know the marks will look a little different. When we had the premium situation, the premium effectively allowed this entity to borrow at 4% market rate. So what you're seeing is that premium or that discount is really an equalizer that allows this lending structure or this investment structure to either force the borrower to pay market rate or allow the investor to achieve a market rate of return. So remember a few moments ago when I said that the premium or the discount is really kind of an equalizer to basically force this investment vehicle to pay interest effectively at the market rate of interest. Okay, actual payments will still be at the stated rate, but we're going to effectively borrow at the market rate. Take a look at this situation here. Now, there are two ways of amortizing either a premium or a discount. One is called the straight line method. The other is called the effective interest method. They both accomplish the job at the end of the day. They get it done, but they come about it different methods. And the straight line method is a kind of more simple way of doing this. Let me just illustrate. So when we had the premium situation, the initial carrying value of that bond was $107,000 because the bond was issued at a premium. So the way this is going to appear on the company's balance sheet is really it's going to have two lines. There's going to be one line that says bonds payable for $100,000. There's going to be a second line on that balance sheet, premium on bonds payable. It's kind of an adjunct account that between these two accounts right here, we have a total carrying value of $107,000 and some change. Now what has to happen is this. By the time that bond matures, we need the carrying value to equal the face value of the bond. Because remember what happens at the end of the bond. The borrower is going to write a check to the lender, the investor, for $100,000. So we need that carrying value to be reduced over the life of the bond. Well, the way we can do that is by taking this premium right here. Let's divide it by 4. So take 7260 divided by 4. That comes out to, what do I have here? $1,815, which, no surprise, matches what I've done right here. Now, I've already put the amortization schedule together for you because it would take a while to kind of work this out by hand, but I think you'll very quickly see what's happening here. What's happening is this. Every year when we make a cash payment to the bondholders. Here's what's going to happen. Cash is going to decrease by $6,000. And interest expense is going to increase by the amount that we see in the table, $41.85. The premium is going to, so interest expense is going up. The premium is going to decrease by the $1,800. So basically what's happening is, over the 4-year period, we're going to make cash payments, okay? So cash goes, this is $6,000 cash going down, $4,100, almost $4,200 of interest expense going up, being recorded on each year's income statement. And the equalizer is this. Remember that with a premium, the effective interest rate is going to be less than the stated rate because the market rate was lower than the stated rate when we calculated the premium for the bond pricing. So the cash payment is $6,000, but the interest expense each year is going to be just shy of $4,200. And the reason is we are systematically each year taking $1,800 away from the premium. As we do that, the premium amount gets smaller and smaller, smaller by $1,815 each time. At the maturity of the bond, the premium account will have a zero balance. The bond's payable account will have the $100,000, and the overall carrying value will be $100,000. And over the life of that bond, the interest expense of $16,740 will be effectively the market rate of interest that was in effect at the time this bond was priced. So we're looking at the same data, okay? We still have the carrying value is $107,260. The premium is $7,260 initially. Nothing has changed there. Now you might remember when we did the straight line method of amortizing premium, we did an equal amount, $1,815 per year, each year for 4 years. And just to kind of prove it to you, let me click back a couple slides here. The amortized premium is over the life of the bond, it's going to be the entire premium, $7,260. It just so happens that the straight line method does it in equal chunks, whereas the effective interest method does it using the carrying value of the bond. So we're going to get to the same spot, but we're going to get to it with kind of an escalating amortization of premium. So let me just explain what's going on here. What you need to do to calculate your interest expense is you need to take the current carrying value of the bond, right? And then you multiply it by the interest rate, the market interest rate that was used to price the bond. Remember, when we figured out the price of this bond, we were using the present value of the market rate. I believe it was 4% in that example. And in fact, it is 4%. And so we calculated the price of the bond using 4% values for the single sum and the stream of cash interest payments. So now, as we amortize under the effective interest method, the premium in this case, we're going to use the market rate of interest to calculate the effective interest. So you take the current carrying value, multiply it times the market rate of interest that was used to determine the price of the bond, and this is going to be our interest expense for year one. Okay. So the first thing you do is you calculate the interest expense for the year. Then what you do is this. You take a look at the cash payment, because that's not going to change. That's what we're obligated to pay the investors. The cash payment is $6,000. If $4,290 of that payment is interest expense, the difference must be the premium that we're amortizing. And we see that right here. Okay? So we're going to get rid of that premium. And then what's going to happen is, now we have a new carrying value. So the carrying value has dropped, and it's, what do we have here? $105,000 and some change. So the new carrying value, $105,550. Just as a reminder, why did that drop? Well, it dropped because as we got rid of some of this premium, the premium gets smaller. The carrying value of the bond gets smaller. Pardon my little chicken scratching there. So take the new or current carrying value multiplied by the market rate of interest, and we've got this next year's interest expense. You'll notice that it's nice when things work out. That's what happens when you do the calculations before you make the video. And then we've got right here, $6,000 payment. That doesn't change, but we've got a new different, and actually if you look at it, it's a slightly lower amount of interest expense. What's the difference going to be? I'm going to just put this over here. The difference is that $1,778. So an observation is this. Using the effective interest method with a premium situation, your interest expense will be bigger in early years. It'll be smaller in the later years. And the reason is because the liability is going down. As time goes on, this liability is getting smaller and smaller. Because the premium is getting smaller, the carrying value is getting smaller. We're multiplying the market rate times a smaller carrying value, but at the end of the day, you're still going to amortize that entire $7,260 premium. You're just doing it in increasingly larger chunks as the carrying value goes down. I'm going to speed this discussion up just a little bit. Not that I don't like spending this time with you guys, but I don't want you to get bored, and it does start to get a little bit redundant, okay? But let me point out a couple of nuances. In those first two illustrations, or just recent illustrations, we looked at how to amortize the premium over the life of the bond using both the straight line and the effective interest methods. Now what we're going to do is we're going to amortize a discount situation. Now you might remember in the discount situation, we were, our bonds pay 6%, but the market rate was greater than 6%. So our bonds were less attractive. They got issued at a discount. You might even remember the carrying value. Initially, the bond issuance price was $93,376. That's why I start this discussion with the bond pricing, because the price of the bond is really its initial carrying value. Now, bonds payable is going to be the same under premium or discount. Let me go over here to a premium situation. Bonds payable is always going to be the same. What's going to be different is this. Instead of having an account that adds to the liability, premium on bonds payable, what happens is you have the discount on bonds payable. That reduces the liability initially, but that liability is going to grow over time. Notice here, back to the premium slide, so I am on a different slide here, the carrying value declined over time. With the discount situation, the carrying value increases over time. All right, so what we're going to do is we're going to take the discount, and that's simply the difference between the face value and the bond price, the initial carrying value. And in this case, we're going to take that overall discount because we're going to do the straight line method here. We will take a look at the effective interest method for discounts in just a minute, but it's very similar to what we did with premiums. So essentially, pardon me, we're going to take that $6,600 and we're going to divide it over the next 4 years equally. Okay? Nice and simple. Each year, we take $1,656 of the discount, and notice what happens. This discount decreases by $1,656. Next year, we'll take another chunk out, and the discount decreases again by $1,656. And just to kind of illustrate, you do that again. You do that 4 times, the discount becomes 0. At the conclusion or the maturity of a bond, I don't care whether it's premium, par, or discount, they're all going to end up here with the same carrying value, which is the face value. The premium will become 0, the discount will become 0. Now I want to illustrate what's happening with the interest expense. So when we make the cash payment, cash continues to go down by $6,000. The bondholders are expecting that interest payment, but the interest expense on the accrual basis in the financial statements is bigger. Why is that the case? Well, here's what's happening. Interest expense on the income statement is going to increase by $7,656. The difference between the actual cash payment and the interest expense is the discount that's being amortized. So that discount is being reduced, okay, over the period of time. And, oh, I see. Sorry about that. It kind of, I'll put this over here. It went behind those years. This light board is terrific technology, but occasionally it's kind of like playing weatherman on TV. You have to know exactly where that marker is. So take away this, is that, remember when I said that discounts are really hidden interest expense? It's interest expense for the company. It's additional investment return for the borrower. Remember, the reason there is a discount is this bond is not as attractive as the marketplace. So to incentivize or to attract investors, we have to be willing to offer the discount. And that discount is giving the investors a bigger return. It's causing the borrower to pay a higher amount of interest than the cash payments. And over the life of the bond, it effectively forces this instrument to bear interest at the market rate. Just like we did with the premium situation, you can amortize this discount using either the straight line method or the effective interest method. Now, I'm going to show you the effective interest method right now, but just to prove it to you, let me go back a slide or two in a second. Remember that discount, $6,600 over here? When we did it the straight line method a moment ago, it was the exact same discount. The only difference, just like we did with the premium situation, instead of taking equal chunks of that discount each year for 4 years and converting the discount into additional interest expense, what we're going to do is we're going to take a look at the discount and we're going to amortize it on the effective interest method. The total discount amortized over the 4 years will be $6,600, but it will not be in equal chunks. What we're going to do is we take the carrying value. Right? In this case, it's that discounted bond price that we came up with. So take that carrying value, multiply it times the market rate of interest that was used to determine the bond price. Now, when we looked at the premium situation, we were multiplying times 4% because that's what caused the premium. These bonds pay 6, the market was 4, these are better than the market. Now, these bonds pay 6%, but the market pays 8%. These bonds are not as attractive as their counterparts in the marketplace. That's what caused the discount. So the interest expense, we calculated there, $7,470. The amortized discount is the difference between your accrual basis calculation of interest expense and the $6,000 cash payment that we promised to the bondholders. So that's where that amortized discount is coming from. The calculations that you would perform for the rest of this table are very similar. For example, you would basically, we'll just do this the second row just to kind of illustrate it. The new carrying value, notice the carrying value is increasing with the discount. You would expect because it has to end up at $100,000. Multiply that times 8%. So interest expense, calculated interest expense for the second year is going to be $7,588. What then happens is the amount of discount amortized is greater because your interest expense is greater, but the cash payment is still $6,000. So the takeaway is this, that discount is hidden interest. It's an additional cost of borrowing for the borrower. It's an additional investment return or incentive for the investor, or effectively the lenders, the bondholders. And what you're seeing here is that with the discount, the carrying value starts smaller and ends at $100,000. Because the carrying value is increasing as time goes on, the interest expense also increases as time goes on. And it's facilitated by this discount that gets amortized. So at the end of the day, really, it doesn't make a difference if the bond is issued at a premium, at par, or at a discount. It is effectively going to bear interest at the market rate when it was priced, and the financial statements are going to reflect that through the balance sheet presentation and the periodic reflection and measurement of interest expense.